And welcome to week 6 project. We're almost done with this project series. You have this one and the next one, and then your last one is basically putting everything together. So we'll go through that one and show you some tips. So here's week 6 project. All right, week 6. This is what we're doing in week 6. Similar to last week, but we're taking it a step further. Now we're going to start testing hypotheses. So hypothetical values are we using, or claims here to test. Okay, we'll also be doing significant tests too. So let's get moving here. Okay, so we have our school data set. We're going to be doing what we're doing to the project business major. We're going to be doing the same thing for the engineering major. For all the project series, make sure you're doing that, going back through and doing. I'll show you one set, and the next one you'll be doing on your own another set. Okay. So for this question here, I'm gonna go ahead and pull it up real quick. I'll just type it in here, put it in here, like we have been doing. And I'll just keep it like this so we can actually see it. All right. So we're trying to develop this hypothesis about the data. Okay. Basically, you know enough about it, you see it, you can hypothesize about it, and then from there you actually test it. So that's what we're going to be doing today. So the first thing we're going to be doing here, like we did before, was to get some information about the actual data. Okay. We need the sample size, the sample mean, and standard deviation. Okay. Now, we already know how to get the sample size, right? I'm going to show you a formula if you wanted to do that. You can do count A if you want to. I'll just show you that. Equals count A. And then when you do count A, it just counts everything in that basically everything inside that box or inside that area, okay? And whatever's in there doesn't matter. If it's a letters or word or numbers, it'll count it. So count 20. Sample mean, what is that? We know that to be average equals average. Okay, well, average. And then you click on the one here where it says average, double click on that. And then, of course, we're trying to do an average of what? The mean cost. We're doing the cost, right? We're working with cost here. So this is the cost. This one here, you don't have to include the label. We're just doing the average for that column there. And then you close the brackets. And now, just trying to see where the sample mean is. Why is this one different? Okay, that's engineering. That's why. Get out of there. Okay, this is perfect. This is it. The next one we're going to do is standard deviation, sample standard deviation, excuse me. So the formula in that one is you just type in equals standard dev. That's what we use. Where is that? STDEV. Why doesn't it come up? Stand dev. It's the same thing as standard deviation of the sample or of the population. So I'll do one stand dev pop. Okay, we're taking the whole population and we're doing it, right? Standard deviation out of all this. Oh, standard deviation out of the whole population. That's what .p is. Close that. We should get, why is this one here changing? Let's see why. If you did the S, let's see what happens. Of the sample. And it looks like we're supposed to be going with the sample, so use that one, okay? Center dev of the sample. And .s is the sample, right? Double click on that, and then now we added our values, put enter, okay? So you can do that, and then now you can format Painter and do like this if you want to, because it's supposed to match the values, right? Next thing we have to do is we have to know the hypothesis value and they gave us there is $160,000. So they gave that to you. I want to make sure that this is the dollar value sign right here. Okay, the next thing we're supposed to get is the standard area, test statistic, and degrees of freedom. Those are all fun, right? So how do you get standard error? You need to take, let's see here, make sure I'm in the right spot. We're going to take the standard deviation, divide that by the square root of sample size. So we're using the standard deviation, and we're dividing that by the square root of sample size. So I'll do that. Okay, here we go. Equals the standard deviation divided by the square root. So you just type in SQ, and there it is. Square root of which number? The sample size divided by, oh, that's the sample size. That's it. Square root of sample size. And we have the standard deviation. There we go. Push enter. And that's right. There's your standard error. And the test statistic is basically you have the equal sign here, and you add, what is it? You're taking sample mean, and you subtract that from your hypothesis value. Sample mean, subtract that from your hypothesis value, and you divide this whole factor. So you have to actually go like this, since we're doing another step. Make sure you put your brackets open and close, and then put that value in there. So sample mean minus hypothesis value divided by, which is your standard error. So divide by that, standard error. 2.54 is your test statistic. Degrees of freedom is always n minus 1, so you take equals this minus 1. Okay, which is your sample size. N is the sample size. N minus 1. It's 19. Now you're going to have your p-values down here, and this is what we're going to be using to get our, to see if it's significant or not at 5%, right? All right. So for here, we're going to we're using a thing called t-dist, excuse me. I'll show you that. Equals t distribution. And we're going to take, for this one, we're going to add in there your test statistic, which is what we're using for it. And that's the x value, the degrees of freedom, which is that 19. And we're going to use true on this one. So you just double click on that. And then you close your brackets out and push enter. Very good. So your upper value is a little bit easier. You use 1 minus the lower value. 1 minus, of course you got to put equals. 1 minus lower value. Okay, and then from here, here's your p-value. You can actually take 2 times this one here. Okay, 2 or equals 2 times that value. All right. So what we're doing is we're comparing it, right? And this is how you tell if you're going to be rejected or not. Okay. So we're comparing it for the 5% significance. This is 5%. Right now it's the p-value of 0.02. And we're comparing that value to here and see if it's significantly different or not. Let's see here. Looks like it's lower, so it's supposed to be higher, okay? So you reject the at this level here, you would reject the null hypothesis. Okay. All right, so that's that one. The next one we actually have to do is a little bit more difficult. You're working with two different populations. So let me go ahead and get that constructed for us real quick. Okay, so basically you're going to actually do like I'm doing now, copying the data here, creating a new tab, and we're going to label this accordingly. Put it right here. And what you wanted to do is make it bigger, right? So you want to spread out a little bit. And what I'm going to do is on here, I'm going to actually highlight all this and put merge. And I'm going to put down here business. And the reason why we're doing this is because our second question is asking us something for us to do. What I'm going to do is I'm going to go ahead and copy this whole data over here. Not because I want to keep it copied, but I'm going to use it as a template for the other piece. I'm going to put on here engineering. So now you have two data sets, engineering and that, right? And from there, I'm actually go to the engineering job and grab that. Put it right here, school type, and boom. Control C, Control V. So the reason why I did that is because you wanted to be able to compare the two, right? Your question was, maybe I can go like this a little bit so you can see. Insert. There we go. Maybe it will be big enough. Hold on. So your question is, and this is, you can actually label it if you want to down here, question 2. For this one, you have to actually compare the two. This is what you're doing, okay? Sample. You're going to conduct a 2-sample test. Hypothesis test to 10% significance. Okay. And here's your hypothesis. Okay, so let's do that. And you guessed it, we're going to be doing the data analysis tool pack again. Let's see here. Go to my example. Okay, so what you want to do is go to data analysis. Data analysis. We're doing right here, it's called a t-test for 2 samples for means. You want the actual unequal variances, right? Because right here we're saying that assume that the variances are unequal. So you have to actually run that test. If you run the other one, it's not going to be right. You got to actually run the one that says assuming that unequal variances there. They're not equal. Okay, unequal, not equal. Push OK. Now it's going to ask you what your variable is. So we're looking at which ones. Okay, so let's see here. 30-year ROI is what we're looking at. So for both of them. What I'm going to do is, before I do this, I think it'd be helpful for you, is to put down here, right in here, put down biz, like BUS, for business, so you know it's business. And I'm going to go ahead and put in here engineering, ENG, so we actually know that's engineering. Okay. All right, so now what we're going to do is go ahead and run the data analysis tool pack again. And the one with unequal variances, t-test. And we're going to select the first value. So the first one we're going to select is the business 30-year ROI. Okay. Second variable we're going to select is the English 30-year ROI. labels, and we said we wanted it at 10% significance, right? That's your alpha. We're going to put down at 10 for your alpha. And we're going to do output range. And that alpha is important there because it tells you you need a 10%, right? Within 10% significance. So then you put it here. And you actually, I'll put it right here so we can actually move it out of the way. And it did say 10% significance. So 10% alpha. 0.10. And we'll just move it up here so it's a little bit easier to see. There we go. Push OK, and boom. It runs it for us already. So what I wanted to do was make sure this is bigger so we can see it. And I can move them around here. Okay. Okay, so basically how we interpret this is we want to underline that. Here we go, put it over here so we can see. All right, so this is what we're looking at. The hypothesis is right here, right? Here's the hypothesis. Okay. And what we're testing for is this 10% significance level. Okay, and what we're looking at is the actual p-value to see if it's greater than it. Let me move this over here the correct way. And where's the p-value? Okay, the p-value, like I said, highlight the stuff here. You can go ahead and go like this. So the p-value is actually greater than the 10%, right? We can see that. And basically, here's your p-value right here. And what we're looking for here is if we have a larger p-value, that means that the p-value is larger than the actual 10% significance. We cannot reject it. If it was lower, okay? If it was lower, regardless of whatever the hypothesis says, we would reject it. Okay, and basically for here, this one here, we do not reject it because there isn't significant differences in the mean values. Okay, there isn't the differences here. That's what it says. So we use the test of 10%. So, and that's the significant level we set it to. If we change it to 5%, then we will test for 5%. But we tested for 10%, and this one here is actually greater than that 10% right there that we set. Okay, so that's how you interpret this one. Sorry this one took so long, but this one's pretty challenging. All right, see you in the next one.